Well, good evening, everybody. My name's Rick Gering from Naperville Astronomical Association. This is our July Observing Fundamentals meeting, and tonight we're going to be talking about a timely subject, comets, and it's timely because we actually have one in the sky at the moment. So let's see what they're about, and we'll talk about comets in general for a while, about how people have seen them over the centuries, then some discussion of what they really are, and then we'll talk about the one that's out there that we can look at now. So let's see where we end up. Here we go, I think. There we go. All right, so comets have always been sort of surprises in the sky. Thousands of years ago, if you were an astronomer, your job was to make sure that everything was nice and calm in the sky because, you know, that's where the gods lived, and you didn't want unusual things to be happening there. And when unusual things did happen there, like all of a sudden there was a strange looking object that wasn't there before, it was usually taken as meaning something, and often it was taken as meaning something bad. One of the first systematic studies of comets was done by Chinese astronomers over 2,000 years ago, and they tried to make sense of comets by studying the specifics of different comets' tails. And what they were trying to do was to determine from the shape of the tail and the appearance of the tail just exactly what kind of disaster that particular comet was bringing them. The one thing they were the one thing they were sure of was that it was going to be portending some kind of disaster, and they thought that by examining the tails they could figure out what kinds. Well, that didn't work out so well. Okay, the Romans, on the other hand, they often considered comets to be portents of good things rather than bad things. There was a comet that appeared shortly after the assassination of Julius Caesar, and of course Augustus Caesar, his successor, did what all good Roman emperors did when something important happened. He gave the people their bread and circuses, and the comet appeared during the games that Augustus declared after Julius was assassinated. And Augustus proclaimed that the appearance of the comet in the sky after Caesar was assassinated proved that Caesar had now become one of the gods. So that was an instance where a comet was taken as portending a good thing. Another comet appeared, and actually it was Halley's Comet that came back to us in 1986 and will be coming back again in a few decades. It appeared shortly before the Battle of Hastings in 1066, when William the Conqueror and the Normans invaded England successfully. William saw the comet before the battle and interpreted it as an auspicious sign for himself. I don't know whether the Anglo-Saxon king Harold saw the comet before the battle or not, or what he thought of it, but it didn't work out so well for him since he lost. And if you look over on the right there, you see where they have Harold's name written above him. We also have some evidence that apparently even 1,000 years ago, people were accidentally leaving the caps lock on, but that's a different point. Now, it's not just in ancient times that people got a little bit carried away with what comets portended. As recently as 1910, when Halley's Comet came back that year, there was a Frenchman named Camille Flammarion, who is described here in this newspaper article as a distinguished French scientist. I think it would probably be more accurate to say that he was a very talented astronomy popularizer and was very good at getting his name in the newspaper. It was sort of a Neil deGrasse Tyson 100 years before our Neil deGrasse Tyson came along. And after the folks at Yerkes Observatory did some observations that led them to conclude that there was cyanogen in the tail of Halley's Comet. Flammarion alternately told the press one of two stories: either that Earth was going to pass through the tail of the comet, the cyanogen from the tail was going to displace Earth's atmosphere, and we were all going to die of suffocation, or sometimes he would tell them that there was hydrogen in the tail of the comet, and that when the Earth hit the tail of the comet, the hydrogen would cause the Earth to explode and no longer be. So it's not just the ancients who were a little bit goofy about this stuff, and it's a fair question, I suppose, what people will be saying about us in 100 years. But that's where Flammarion was about 110 years ago today. So what are comets really? Where do they come from, and how do they get here, and why? Let's have a look at that. Comets come from two places. There are comets that come from relatively nearby. They're the so-called short period comets, those that come back to visit us in periods of less than 200 years. And they come from the Kuiper Belt and the scattered disk. Now, the Kuiper Belt and the scattered disk are areas outside, beyond the orbit of Pluto. It's sort of the construction debris that was left over after they finished building the solar system. And that debris sort of forms a sort of donut shape. Technically, it's called a torus, T-O-R-U-S, that circles around the outer reaches of the solar system. And the comets that originate in that material and come whooshing from the Kuiper Belt through the inner solar system around the sun and then back to the Kuiper Belt, they generally orbit relatively flat, in an orbit that's relatively flat with respect to the plane of the ecliptic. For those of you who don't know what the plane of the ecliptic is, if you look at the diagram on the screen that shows the sun in the center and the white lines showing the orbits of the planets, you can get a sense that the planets all sort of orbit in the same plane. It's like we're all marbles rolling around a big dinner plate. And Kuiper Belt comets come from above or below the plate, but not at a really steep angle. On the other hand, long period comets, comets that come back in a period that's greater than 200 years, they come from a different place, an almost unimaginably distant place called the Oort Cloud. Again, it's material that's left over from the time of the construction of the solar system, but this is much, much farther away. You can see on the scale on the right side of the diagram, it extends out to 10 to the fifth, which is 100,000 AU, or astronomical units. An astronomical unit is the average distance from the Earth to the Sun. To give you an idea, Pluto orbits at an average of 40 AU from the Sun. So we're talking about the Oort Cloud. We're talking about some place that's 2,500 times as far away as Pluto. The Oort Cloud is not like a donut or a torus. It's a sphere. And comets that originate in the Oort Cloud can enter the solar system at any angle at all. They can come from literally directly above all the way to directly at the side. So we can get comets that have extremely steep angles breaking out of the Oort Cloud and passing through our neighborhood. There's also a group of comets called the Jupiter Family Comets. They are very short period comets, less than 20 years, and they are former Kuiper Belt comets, or parts of Kuiper Belt comets that broke up during one of their passages around the sun, that have been captured by the gravity of Jupiter. And if you wonder why it is that Jupiter seems to get blamed for capturing things with its gravity a lot more than any of the other planets do. It's because Jupiter's mass is 2.5 times as great as all the other planets in the solar system combined. So if something is going to if there is something in the solar system whose gravity is going to catch a passing object, Jupiter's the one who's going to do it. And it has done that for a number of short period comets that now orbit around, really more around, as much around Jupiter as around the Sun. Cometary orbits, as we said a moment ago, can come from any angle. You can see on the right-hand side, Comet Hale-Bopp, that many of you will remember from 23 years ago. It had a parabolic orbit. It came from way out in the Oort Cloud, may never return, and came through the solar system at a very steep angle, as you can see. Other comets like Halley. Halley is very nearly in the plane of the ecliptic, as we're going to see later. It's one of the few comets where Earth actually crosses its path twice, coming and going rather than just once. So cometary orbits can pretty much come from any direction and be narrow or fat or up and down or sideways or any shape at all. So what are they made of? Well, they've been called dirty snowballs. They've been called cosmic rubble piles. And the fact is, they're pretty much a little of both. When we look at a comet, the front of the comet, the business end of the comet, has two parts. There's a solid nucleus inside a gaseous coma. And then trailing behind the coma, there are we call it the comet's tail, but it's really two tails, as we're going to see shortly. So let's have a look, to start with, let's have a look at the nucleus and see what that's about, because that's the solid part of the comet. The comet's nucleus is a loose structure. It has dark rock outside and a mixture of rock and ices inside. The ices can include water ice, carbon dioxide ice or dry ice, frozen ammonia, frozen methane, and the dust, the rocky part of the comet, is primarily composed of carbon, hydrogen, oxygen, nitrogen, and some silicates. The most important, in some ways, the most important characteristic of the comet's nucleus is that it's surprisingly small, usually less than 6 kilometers or 10 miles in diameter. The comet that is currently gracing our skies, called NEOWISE, is about 3 miles across, but there are much larger ones. Hale-Bopp, for example, was a relatively huge comet which had a nucleus 60 miles across. Spacecraft have done flybys of a number of comets. We have a sort of a rogues gallery of them that we can go through. Temple 1 was photographed from a distance pretty far away. You don't really get a good sense of the looseness of the structure. You start to see that a little more in the photograph of Comet Hartley and much more so in Comet Wild. You can see where the surfaces are sort of broken up. The best ones that we have are photographs that were taken by the Rosetta mission to what I'm just going to call Comet 67P, because I'm not even going to try to pronounce the rest of its name. And this is a fairly long view of the comet taken by Rosetta, but it got much closer. And the closer it got, the more we can see just what a comet is really about. It's certainly not a regular looking place. It's not smoothed out. It's very rough. There's a lot of loose material that we can start to see in this view. You can see a lot of loose boulders on both on the right side and in the saddle of the image. It gets a little bit closer, and we find out that there's basically loose material pretty much everywhere. There's very little solid surface underneath it. It's mostly that loose stuff that we're seeing. And when we get very close indeed, we can see just how irregular the surface is. And you can see in this particular image over to the right, there was a lander that Rosetta successfully landed on the comet. It was the first time we had a successful soft landing on a comet. But unfortunately, as you can see here, Philae ended up in a crevice where there was no sunlight, and since its power was solar powered or designed to be powered by the sun, it never was able to establish communication back to the Rosetta spacecraft or through it to us because it never got the sunlight it needed for its power. The coma forms around the nucleus. Now, way out in the solar system, as they're coming in from the Kuiper Belt or the Oort Cloud, when they're out in the neighborhood of Neptune, Uranus, Saturn, even Jupiter, we can't see the comets because they're illuminated only by sunlight, and their albedo, or the amount of sunlight that they reflect, is only about 4%. They're very dark things. And if all we had was sunlight to see them by, we would hardly ever be able to see them until they were right on top of us. However, about 3 astronomical units from the sun, 3 times the distance of the Earth from the sun, it starts to get warm enough that the nucleus begins to warm up, and water ice on the sunward side of the comet sublimates directly from a solid to a gas. Sublimation is like evaporation, but it doesn't go through a liquid phase. It just goes directly from being solid water ice to being water vapor. And there's a little bit of carbon monoxide that's involved in the mixture as well. Now, that vapor escapes through cracks and fissures in the loose structure that we were just looking at. And as it comes out, it carries dust particles from the comet's surface off the surface of the comet and into the space around it. And that material is what forms the coma, which turns into a rounded shell around the nucleus. And sunlight reflecting off the dust in the coma is the principal way that we then are able to see the comet. There is also some additional light from fluorescence that the water vapor fluoresces in the ultraviolet light from the sun, and adds a little bit of light in that way. So when we see a comet's head, what we're seeing is, we don't see the nucleus, which is just a piece of dark, brittle rock. We see the coma around the nucleus. And these photographs of 67P, you can see very graphically where the vapor is coming out from inside the comet, and it's carrying dust out with it. And so you're basically watching a coma being built in these photographs. Now, of course, the defining characteristic of a comet, at least as we understand it, a classic comet that we see in the sky is the comet's tail. And as we said earlier, it's got 2 tails. Let's talk about where they come from. There they go. The first of the comet's tails is called the gas tail, or the ion tail. It's material that comes off the coma, and it's ionized and formed into a long tail by the solar wind. Now, what's the solar wind? The solar wind is a constant flow of charged particles that comes off the sun in all directions, and it causes a number of things. Most pleasantly, it causes the aurora borealis, and has a number of other effects. But in the case of a comet, it ionizes the gas from the coma and pushes it away from the sun. So the ion tail always points directly away from the sun. If you follow the ion tail back to the head of the comet and continue on that line, that's where the sun is going to be. The comet tail can be very long, or the ion tail rather, can be very long. The tail can be long as the distance from Earth to the sun, which is nearly 100 million miles. And it has a very characteristic electric blue color that comes from ionized carbon monoxide gas. While it's very pretty, it's kind of delicate, and you're going to need clear, dark skies to see it. I do not think you're going to be able to see it with NEOWISE unless you're someplace very, very dark indeed. The other tail that the comet forms is called the dust tail, and that's a little more simple in one sense, and a little more unusual in another. It's simple in the sense that it's just dust that came off the comet and then out of the coma, but what forms it into a tail is a little unusual because it's formed into the tail by solar radiation pressure, which is the physical pressure, electromagnetic pressure that's produced by photons or light that is released by the sun. The light actually pushes the dust into the shape of the tail, combined with the movement of the comet through space, and so the dust tail generally points away from the sun, but it then bends a little bit towards the comet's orbital path because of the comet's motion. Dust tail is much shorter than the ion tail, usually no more than 6 million miles. Easier to see from Earth, so that's good, and it has a color that can be anywhere from grayish to yellowish. So there we have the gas tail. You can see it's much more, much less dense than the dust tail, and not as easy, understandably not as easy to see. Goes directly away from the sun, whereas the dust tail goes generally away from the sun, but you can see how it bends there, caused by the movement of the comet through space. Hale-Bopp had a beautiful ion tail and a wonderful dust tail as well, and this is why Hale-Bopp was indeed one of the great comets. Comets are also important for another reason. Without comets, we would not have meteor showers. As we saw in those pictures of 67P, as the comet comes near the sun, once it gets about twice as far away as Mars or 3 times as far away as the Earth, it starts shooting out quite a bit of dust and gas, as you saw in those pictures. And each trip through the solar system can cost a comet 1% of its mass. To give you an idea of what that translates to, when it was closest to the sun, Hale-Bopp was losing 1,000 tons of dust every single second. Now, smaller comets aren't going to lose as much, but they are still going to lose a relatively measurable amount of their mass to that. So as the comet comes through the solar system, it's basically it's like Pigpen in the Peanuts comic strip, for those of you who still remember peanuts. It's leaving a trail of dirt and dust behind, and sometimes those cometary orbits intersect Earth's orbit. As you can see here, that's what's happening. Usually, the orbit of the comet only intersects our orbit on one side because we're orbiting in the plane of the ecliptic, and the comet is usually orbiting in an angle to the plane of the ecliptic. So by the time it gets to the other side of our orbit, it's either way above or way below the plane. And that's why we have meteor showers on the same day. They repeat on the same day every year, because the dust stream that causes the meteor shower exists at a specific point in our orbit. We come back to that point in our orbit every year, and that's why we see the meteors. The meteors that we see in a meteor shower are little pieces of dust that was left in the trail of the comet. As they enter the Earth's atmosphere, they burn up in a rather spectacular manner, and we get the benefit of that. Lots of meteor showers, and their parent bodies are indicated. Like I said earlier, Comet Halley is the only one I know of where we hit its orbit twice. We run into it on May 6th, which causes the Eta Aquarid meteor shower, and we come back again on October 21st and hit it on the far side of our orbit, where it causes the Orionids. Comets also give us the Zodiacal Light, which most people have never seen because it's a difficult thing to find. It's a tall triangle of light, but you're only going to see it under very, very, very dark skies, and it rises from the horizon before sunrise or after sunset, and it's random cometary dust that's just lying in the plane of the ecliptic, that dinner plate that we're all rolling around on. And when the ecliptic makes a steep angle to the horizon, as it does on spring evenings and autumn mornings, you can see sunlight reflecting off that after the sun has gone down or before it comes up. The sun is down below the horizon, but it's lighting up that dust that is in the plane of the ecliptic and giving us that nice, pretty, subtle triangle of very gossamer, delicate light. So what do comets look like in telescopes or binoculars? Well, pretty much like what you would expect. Comets with tails look pretty much like this. Unless you're in extremely dark skies, you're going to see only one tail. You will not see the ion tail unless you're someplace pretty remarkable. But you will see the bright coma at the front, and then the brownish, grayish, yellowish tail extending out beyond it. Sometimes a comet comes right at us, and that gives us a tailless comet because the comet's tail is sticking out behind it, and that's pretty much what that type of comet looks like in a telescope or in binoculars, for that matter. And there's another way you can see comets in telescopes or binoculars, and that's when they break up and run into something. And again, because Jupiter has so much mass and is so attractive by gravity, Jupiter is usually what they hit. The comet Shoemaker-Levy 9 broke up rather spectacularly and ran into Jupiter in 1994, leaving that series of basically looked like bullet holes across the poor thing that were easy to see. And more recently, in 2009, an unnamed comet flew into Jupiter, and we were able to see the scar that it left in telescopes as small as 4 inches when that happened 11 years ago. And that brings us up to today. Our comet du jour is called C2020 F3 NEOWISE. Let's go through that name and wonder how any self-respecting mother could name her child that. The C means that it's not a periodic comet. A periodic comet would begin with a P, like in P67 that we saw earlier. A periodic comet is one whose estimated period is less than 200 years, or whose actual period has been determined by observation at more than one passage past the sun. And so a C comet is one that does not have an estimated period of less than 200 years and has not yet been calculated accurately by at least 2 perihelion passages. The 2020 and the F3 just tell us when it was discovered. The year is divided into 24 half months that are listed alphabetically. A is the first half of January, B is the second half of January, etc. So 2020 F3 means that this was the 3rd comet discovered during the second half of March 2020, and the remainder of the name is the name of its discoverer, which in the old days used to be things like Schumacher-Levy, because it was people who were discovering comets. Now, most comets are discovered by space telescopes whose job is to spend all day, every day, looking for things near Earth. And this particular comet was discovered by a space telescope called NEOWISE, whose job is to look for near-Earth objects in infrared light. So that is why the comet is called what it is. This is what it looked like when it was a morning object earlier in the month. Chris Almanza, who many of you know is a very active NAA member, took this photograph morning of July 10th. It's also pretty much what the comet looked like as recently as last Friday in the evening sky. Now, since then, it has gotten dimmer, although it may not have gotten all that much dimmer. We'll talk about that in a moment. But let's talk about some of the statistics on NEOWISE. As I said earlier, it's got about a 3-mile or 5-kilometer nucleus, which is pretty average for a comet. It is coming in at a very steep angle to the ecliptic, 128.9 degrees. So it's definitely not from around here. Its estimated period before this passage was 4,500 years. Changes in its orbit as a result of this pass through the solar system are expected to increase it to 6,800 years before it comes back again. It has a parabolic orbit, which also tells us that it's coming from a very long way away out in the Oort Cloud. It reached perihelion, which is its closest point to the sun, back on July 3rd. It was about 3/10 as far from the sun as Earth is, or about 27 million miles. Its close approach to Earth will be on July 23rd, and it will be 64 million miles away from us at that time. So that's still to come. Now, how do you find it in the sky? Well, right now it's in a way being kind of nice to us because it's kind of making a line underscoring the Big Dipper, as you can see in this chart here. You see the Big Dipper up there at the near the top center of the diagram, and then you have the red line showing the path of NEOWISE and where it's going to be on various dates coming up. this is a little more accurate way to find it. This is the view of NEOWISE. If you look on the left-hand side, we are looking directly northwest. You can see the row of lights where the horizon is in this diagram. This is done with a planetarium program called Stellarium, by the way, Stellarium. It's freeware. You can download it. If you Google Stellarium, it'll take you to the site where you can download it, and it will tell you all sorts of interesting things about what's going on in the sky if you mess around with it. You can see where NEOWISE is pretty close to the horizon at 10 o'clock on tonight. It's about 20 degrees above the horizon, as I've indicated on the legend at the top. It's about magnitude 3.4 was the estimated magnitude that it would have at this point. I don't know if that turned out to be accurate, but for those of you who aren't familiar with the magnitude scale, it's sort of like golf scores. The brighter something is, the lower its magnitude is. The dimmer it is, the larger its magnitude is. The naked eye limit is magnitude about 6.5, but in suburban skies, you're lucky if you can see naked eye anywhere past magnitude 3. So right now, NEOWISE is getting to a point where even after you find it, you may not be able to see it naked eye. I guarantee that you will not be able to find it naked eye. You will definitely need binoculars to find it. And how would you do that? Well, if we look at the picture on the right, which is a little more detailed, we're going to go straight up from northwest, which is 315 degrees if you have a compass on your phone. The direction you want to be looking is 315 degrees, which is due northwest. And if you, let's see, tonight, what would be a good way to find it? Well, if you take the stars of the Big Dipper, if you take the star at the back left corner of the Dipper's bowl and go straight down, you'll run into those two stars, fairly bright stars, forming the bear's back feet. Once you get to those stars in your binoculars, use those as a road map to follow a line to the right and just slightly up, and you'll go about 1.5 times the distance between those two stars, and that should bring you right to the comet. If it's clear out tonight, and looking out my window, I don't think it's going to be, but if it were, that is what you would do. We have charts like this. We'll go through them for every day from now till the end of the month. This presentation will be available on the NAA website. If you go to where you went tonight, and you'll find a link that says click here for prior programs. If you click there, you can find this and pull it up. And so if you go out to try to see the comet a week from now, you can run through these at the get it on the website, run through these, and get the appropriate chart and have a look at it then. But let's go through them quickly here. This is tomorrow, the 22nd. It's 10 o'clock, 21.5 degrees above the horizon, magnitude 3.6. So it's a little bit dimmer still. And tomorrow night, I think I'd be inclined to do largely the same thing, follow that line straight down from the lower left corner of the Dipper to the bear's rear feet. And then once I got there, if I had not run into the comet on the way, which I probably should have, but if I didn't, once I get to those stars, just bounce up a little bit and should be able to find it on the way back. The next day, it's a little bit higher in the sky, but a little bit dimmer. And now the moon is going to start becoming a factor. Starting the day after tomorrow, the moon is will still be up at 10 o'clock at night. And on the 23rd, it shouldn't be too bad. It's going to set at 10:36. It's pretty far down in the sky. It's in Leo, and it's 35 degrees, 14% illuminated, and the 35 degrees is how far it is from the comet. So 35 degrees is pretty close, but it's going to be low enough in the sky, and it's going to set early enough that it hopefully will not interfere too much. Also, if you decide to go looking for the comet the day after tomorrow, there will be an ISS pass. The International Space Station will be going by from 9:53 to 10 o'clock, going from northwest to northeast. It'll only get about 15 degrees above the horizon, but if you see something bright that's moving down near the horizon around the time that you're looking for the comet, don't go thinking that that's the comet moving that fast. The comet doesn't move anywhere near as fast as the space station. So how would you find it on the 23rd? I think here I would use the bowl of the Big Dipper to get myself to that star that forms sort of the knee of the bear's back leg, up at the top of that narrow green triangle that ends with his back feet, and then slide down and to the right from there in order to find the comet. 24th, moon's 23% illuminated, so it's considerably brighter than it was on the 23rd. It's a little farther away, but still close enough that it will be an issue. Sets at 11:05, so you probably do not have the option of waiting until the moon sets to look for the comet. And again, looking at the right hand diagram, I would get to the bear's knee, and then slide off to the down to the left. You can probably see not only the star making the knee, but also the comet, which is just the comet is just below it, left of the C on the legend there, and to that star, and also the star to the lower right of the comet. You can probably get all three of those in your binoculars at one time, and use the triangle as a way to identify the comet. And so that's what I would do on the 24th. 25th, it's a little higher in the sky, not quite as bright. Moon is bigger, but farther away. And we have another space station pass coming through, so don't get confused by that. Again, I think you're going to have to use the knee of the bear and then scan directly to the left from there until you run into the comet. 26th, you got the moon 60 degrees away. But it's 45% illuminated, so it's going to be throwing light an awfully long way, and it will almost certainly interfere to some extent with observing the comet. Again, I would go to the knee and head west until I picked up the comet. The comet will look distinctive enough, hopefully still at mid-magnitude 4, that you'll be able to recognize it when you roll across it. Be sure the sky is starting to get decently dark before you go looking for the comet. By the way, if you try to find it while the sky is too light, it's going to be infinitely more difficult. The darker the sky is, the easier it'll be to pick up the comet. All right, so on July 27th, you got a pretty big moon, but it's at this point it's getting reasonably far away. You're going to have some interference, but it probably won't be fatal. And again, we have another space station pass. This one's going to be getting up a little farther in the a little farther above the horizon, but then again, NEOWISE is going to be farther above the horizon as well. So again, we're going to be looking at this point. I think I'd probably use the star at the back corner of the Big Dipper, scan down and to the left to pick up that that star at the bear's hip, and then follow a line just a little bit, not quite exactly that line, until I got to the comet. 28th, you can see we're getting farther and farther away from that 315 degree radial that we started out with. So we're about halfway between west and northwest now. The moon's pretty bright, but it's nearly a quarter of the sky away in the constellation Libra. At this point, I think we're going to have to stop using exclusively the Big Dipper and start using a constellation called Canis Venatici, which is that little green line directly above the comet. The brightest star in that constellation, the one at the left end of that green line, you should be able to pick up, hopefully naked eye. If you follow down, if you scan below the handle of the Big Dipper, you will hopefully be able to pick that star up. And if you go directly down, straight down from that star, right towards the horizon, you should run right into the comet. So that should be a reasonably easy way to find it on the night of the 28th. 29th, again, we've got a space station pass. It's going to be getting high enough in the sky that it would be worth taking some time to watch the space station in its own right. It's going to get up to 57 degrees above the horizon, and after it crosses that 57 degree point and starts coming back down, it's only going to get down to about 40 degrees before it disappears. And if you're watching that happen, you should be aware that when you see it disappear 40 degrees above the horizon, you have just seen the shadow of the Earth extending out into space, because that's what made the space station disappear, is when it flies into the Earth's shadow. But going back to the comet, here we're getting close enough to that little group of stars to the left of the comet that I think maybe we can start using them. If we go from the end of the Big Dipper's handle to the bright star in Canis Venatici, the one that we used yesterday, and then continue in the same line for about the same distance, you're going to run into a really almost unmistakably cluttered bunch of stars. It's called the Coma star cluster. It's a whole bunch of stars will all of a sudden appear in your binoculars, at least if you're in a fairly dark place. And if you then go from there directly to the right, you should run into the comet. That's probably more than a binocular field, so I don't think you're going to be able to get the Coma cluster and the comet in the binoculars at the same time, but at least you can use the Coma cluster as as part of your roadmap to find the comet on the 29th. On the 30th, again, the moon's awfully big. I mean, it's 87% illuminated, but it's 100 degrees, more than a quarter of the sky away. So it's not as bad as it could be. And now the comet is certainly within a binocular field of the Coma cluster. So if you use the star at the end of the Big Dipper's handle through the star in Canis Venatici to find the Coma cluster, you should be able to see the comet at the right edge of that same field, although it won't really be among the stars of the cluster yet, but pretty close. And then finally, July 31st, which is the last night that I've covered here. We've got a huge moon, but quite a ways away. We've got a space station passage. It's going to get high enough that it'd be worth having a look at. Again, it's not going to get all the way back down to the horizon. It's going to disappear while it's still literally halfway up the sky at about 45 degrees when it flies into the shadow of the Earth. And in the interim, the space station is also going to make a close pass by the star Arcturus, which is the bright star at the upper left corner of the left-hand view here. So that passage actually will be worth looking at for more than one reason. And then we have, of course, the comet, which at this point is going to be right on the edge of the Coma star cluster. It should make a pretty impressive view if it doesn't fade too much between now and then. So hopefully that will be helpful to you when you go out to look at the comet. I certainly encourage you to do that. Try to find someplace as dark as possible. The darker it is, it will not only be easier to find the comet, but it will look a lot more impressive once you do find it. And as far away from city lights as you can get is that's what you're looking for. However, with all of this, you have to remember one thing about comets. They're like cats. They have tails and they do precisely what they want to do. It's entirely possible that between now and the end of the month, NEOWISE might fade to the point that it's no longer a binocular target. That could happen. I'm hoping that it won't, but no guarantees. When it comes to comets, there's never a guarantee. So that's about all I've got. If anyone has any questions, be happy to answer them.
We do have one question from Steve.
Okay.
He said, when a comet is faint, is it often difficult to discern? Is there a good way to pick out the comet from faint stars?
I'm sorry, is there a good way to pick out the comet from what?
So basically, if the comet gets too faint, is there a way to tell that it's a comet versus just a star?
Not that I'm aware of.
I've kind of found sometimes if I'm using a telescope, if I give the telescope a little bit of a tap, it kind of forces my averted vision, and you can sometimes pick out that tail a little bit more if the tail is too faint. I think in binoculars, you're probably still moving enough that you would see that there's more to it than just a faint star, I would think.
Yeah, I mean, there is, I know, boy, is it Celestron or Lumicon? Somebody sells a comet filter. I've never seen one, I've never used one, and I have never heard anyone actually talk about them. I don't know what they do. I don't know if there's anything in the spectrum of the comet that you could make it jump out with a filter, the way you can make a planetary nebula jump out with an oxygen filter. But that's a possibility, but I just don't know the answer.
All right.
Anything else?
That was the only question we got. A couple thank yous, but that was the only question.
Okay, well, thank you all for putting up with me. I hope you'll all take the time to go out and try to run down this comet. They are few and far between, so take advantage of it while you can, because that's what I'll be doing. And till then, see you next time. Thank you. Good night.